Welcome back to the Deep Dive. Today, we're tackling a project called the ARPA network. It's pretty complex on the surface.
Yeah, it is.
So our mission is to break it down, make it simple, and really focus on its main product, Randcast, and understand why it's been getting some serious attention lately, especially from investors.
Absolutely. And what's really interesting, I think, is ARPA's backstory. It wasn't always about Randcast.
Oh.
No, it started back maybe 2018 as a really ambitious academic project. They wanted to build this whole network using something called multi-party computation, MPC. The goal was privacy-preserving computation.
MPC sounds heavy.
It is. And the founders, they realized pretty quickly that, well, MPC was just too difficult for where Web3 was back then. It needs huge amounts of computation real time, which made it super slow and expensive for, practical commercial use.
Ah, okay. So not quite ready for prime time.
Exactly. So they pivoted. Smart move, really. Instead of trying to, boil the ocean with these broad privacy tools, they zeroed in on one very specific, very needed, and commercially viable problem. Verifiable randomness. They saw the market needed something straightforward, quick, and fundamentally fair.
Okay, let's unpack that then. The problem they solve. Because my first thought is blockchains are meant to be transparent, trustworthy, right? So why can't they just roll a die themselves? Why need ARPA?
That's the perfect question. It hits the core conflict. Blockchains, by design, have to be deterministic.
Deterministic meaning.
Predictable.
Extremely predictable, yes. It's essential. Given the same input, the same transactions, every single node on the network must get the exact same result. That predictability is the foundation of their security.
Makes sense. Otherwise, nodes wouldn't agree on the state of things and it all falls apart.
Precisely. But that very predictability makes true unpredictable randomness impossible on-chain. If a developer tries to use something internal, like a block hash or a timestamp, well, a miner or validator could actually manipulate the outcome.
They could just say, refuse to include certain transactions or even discard a block if they don't like the random number it produces, waiting until they get one that benefits them. It completely breaks the fairness aspect.
Right, I see. So you can't trust the chain itself for randomness.
Not for provably fair randomness. And that's critical for so many Web3 applications you interact with. Think about games.
Yeah, like getting a rare item drop. Or loot boxes.
Exactly those. Or picking a winner in a decentralized lottery. Or even distributing unique treats when a popular NFT collection mints. You need genuine unpredictability.
Okay, so ARPA steps in to provide that, a kind of decentralized, tamper-proof, random number generator.
That's the idea. It fills that specific gap.
I get the need now, definitely, especially, thinking about some messy NFT mints I've seen. But how does something outside the blockchain guarantee that fairness? How does it avoid just becoming another single point of failure itself?
Good question. That leads us straight to their core tech idea, the cryptographic method they use. It's called Threshold BLS Signature Schemes, or TSS-BLS. Let's try an analogy. It might make it clearer. Imagine there's this super high security vault, and inside is the winning number for a huge global lottery.
Got it. Big vault, big prize.
Now, instead of giving the one secret key to open that vault to just one person, because, what if they lose it or get bribed? You do something clever. You break the key into, say, 10 pieces.
Okay.
And you give each of those 10 pieces to 10 different trustworthy individuals. These are like the ARPA network nodes.
The collective key holders.
Right, exactly. Now, here's the threshold part. To actually open the vault and get the winning number, you don't need all 10 pieces. You only need a certain number. Let's say 7 out of the 10.
I see. So even if a couple people lose their key piece or maybe even try to sabotage things.
Or go offline, yeah.
You can still open the vault as long as enough of the others cooperate. 7 out of 10.
Precisely. No single node, no single key holder can control the outcome or prevent the random number from being generated. And critically, the final result, the number itself, can be instantly verified cryptographically by the system because it requires that threshold of signatures.
So it's distributed trust baked into the math.
You got it. TSS-BLS ensures the network collectively generates the number, and the proof, the signature, is also distributed. Cheating becomes mathematically infeasible.
Okay, that makes sense. So clarifying again, ARPA network isn't its own blockchain then, like Ethereum or Solana. It's more a service layer.
That's exactly right. Think of it as infrastructure. It's designed to be blockchain agnostic.
Meaning it can work with different chains.
Yes. Ethereum, BNB chain, Base, others, it works alongside them.
Yeah.
The network itself consists of these distributed nodes, the operators doing the cryptographic work, and then it uses smart contracts deployed on those host chains.
And what do the smart contracts do?
They manage the requests for randomness, handle payments or rewards for the nodes, and, crucially, verify the random number signature generated by the node group before delivering it to the application that asked for it.
Okay, cool tech. But security is always the big question in crypto, isn't it?
Mm.
How do they stop someone really powerful, maybe a whale or a big exchange, from just taking over enough nodes to break that threshold? Building security from scratch is incredibly hard and expensive.
You've hit on probably their most significant strategic advantage right now. This is where it gets really interesting, especially in the last year or so. They integrated with Eigenlayer.
Eigenlayer, restaking, right?
Exactly. ARPA became an actively validated service, or AVS, on Eigenlayer.
Okay, translate that for me. What does being an AVS mean for ARPA security?
It means ARPA essentially gets to borrow security directly from Ethereum. It's a massive shortcut.
Oh.
Instead of only relying on their own native ARPA token to secure the network, which requires building up its value and convincing node operators to stake it,
Right.
ARPA node operators can now restake ETH as collateral. So they lock up valuable Ether.
Right. And if any of those node operators try to cheat, try to manipulate Randcast, their restaked ETH gets slashed.
Slashed, meaning taken away.
Penalized.
Yes, a significant financial penalty. They lose a chunk of their valuable ETH. This leverages Ethereum's huge economic security. It makes attacking ARPA incredibly expensive, likely prohibitively so.
Wow, okay. That is a big deal. It sidesteps needing to build their own multi-billion-dollar security layer from day one. Is there a downside, though? Does it make them too reliant on Ethereum?
That's a fair question, the dependency aspect. But strategically, for competing right now, it's brilliant. It's highly capital efficient. The TSS-BLS tech provides the mechanism for fairness, but Eigenlayer provides the massive economic guarantee that the nodes running that mechanism have too much skin in the game to cheat.
Okay, skin in the game via ETH.
Correct. And there's another technical advantage built into the TSS-BLS itself. It's designed to be asynchronous and non-interactive.
What does non-interactive mean here? Less chatty nodes.
Kind of, yeah. The nodes doing the key generation and signing don't need constant back-and-forth communication rounds to agree on things. This dramatically reduces latency.
Latency. So the time it takes to get the random number.
Exactly. Developers need that randomness fast for a good user experience, especially in games. Being non-interactive makes Randcast quicker, more efficient, and often cheaper compared to older methods that required more complex coordination.
Faster, cheaper, more secure. Sounds like a good combo. Is it actually being used?
Oh yeah, this isn't just theory. Randcast is their flagship product, using this whole TSS, BLS, and Eigenlayer setup. And their main target market is clear. Web3 developers, especially in gaming, metaverses, NFTs.
Any big names using it?
They have a notable partnership with Cradles, which is aiming to be a AAA-level MMORPG. That's a serious use case.
And numbers. Any metrics on actual usage?
They do share some. Randcast apparently processed over 5,000 requests just on the base network, which shows developers are integrating it. And the security side, the AVS integration, attracted over 208,000 restaked ETH. That's a significant amount of collateral backing the network's honesty.
208,000 ETH. Wow. That's quite a lot of borrowed security.
It really is. And then there's the institutional validation, which we mentioned earlier, that $6 million strategic investment back in May 2024.
Right. Who was involved in that again?
It was led by Laser Digital. Now, Laser Digital is the crypto arm of Nomura, the giant Japanese investment bank.
Okay, Nomura, that's serious TradFi money noticing them.
Definitely. And alongside them were Defiance Capital, a well-known crypto venture firm, and importantly, Animoca Ventures.
Animoca, the
Yeah.
big Web3 gaming and metaverse investor.
Exactly. Their involvement really underlines that validation of ARPA's pivot towards gaming and randomness. It signals that major players believe this specific focus is the right strategy.
So the money confirms the strategy, and are they stopping at randomness? Or is there a bigger picture?
There's a much bigger vision. While Randcast is the focus now, the ARPA team is already researching infrastructure for things like verifiable AI and zero-knowledge machine learning, ZKML. They want to be the go-to provider for these kinds of complex cryptographic computations in the future.
Okay, verifiable AI, ZKML. Sounds like they want to tackle some really hard problems down the line.
That seems to be the long-term play, become a core piece of Web3's computational infrastructure.
You know, this is a great point to quickly pause and remind our listeners of something.
That's right. If you're enjoying how we break down these complex projects like ARPA into hopefully simpler pieces, and you want more deep dives just like this,
Make sure you subscribe to our channel, CryptoBox.
We do all the digging and research so you don't have to.
Okay, so we've covered the tech, the security boost from EigenLayer, the market focus, the big investment. It sounds pretty promising. But let's dive into the risks. There must be challenges, right? Nothing's perfect in this space.
Absolutely. And there are some significant ones for ARPA. The first, and maybe the most obvious, is competition.
Who's the big competitor?
The elephant in the room for verifiable randomness is Chainlink VRF. Chainlink is the established giant. They have enormous brand recognition, existing integrations, huge network effects.
So ARPA is the David going up against Goliath here.
Very much so. Taking meaningful market share from Chainlink is going to be an uphill battle. Even with better tech or security arguments, brand and existing relationships are powerful moats.
Okay, competition. What else?
The second major risk is economic, specifically around their tokenomics and vesting schedule.
Uh-oh. Tokenomics. Always tricky. What's the issue?
Well, firstly, the token model seems to be inflationary right now, mainly due to staking rewards. But the critical point is the vesting cliff.
Vesting cliff, meaning when early investors in the team get their tokens unlocked.
Exactly. According to the source materials we reviewed, it looks like all remaining locked tokens for early investors and the team are scheduled to become fully liquid, completely unlocked by early 2025.
All of them. Around the same time.
That seems to be the timeline, early 2025.
Oof. That sounds potentially very bad for the token price. Like a huge supply dump waiting to happen.
It's a serious risk. You have potentially large holders who might have been waiting years, who could decide to sell a significant portion of their holdings all at once as soon as they unlock. This creates a massive potential overhang of sell pressure.
Which could crush the price no matter how good the tech is doing.
It could certainly put a damper on things, yes. It's something potential investors or users definitely need to be aware of heading into 2025.
Okay, competition from Chainlink, major token unlock risk. Any other big concerns?
There's a third one, more on the technical and governance side. Centralization risk.
Centralization. But isn't the whole point that it's decentralized with the nodes and threshold signatures?
The core randomness generation is, yes. But sources point out that some key control mechanisms, specifically crucial smart contracts like the main AVS controller on EigenLayer, appear to be managed by a single external-owned account, an EOA.
Hold on, what's an EOA in simple terms? Why is that risky?
An EOA basically means it's controlled by a single private key, like a standard crypto wallet. So one key, potentially held by one person or on one system, effectively holds the master controls for managing their entire EigenLayer security integration, including the parameters around that restaked ETH.
So a single point of failure. If that one key gets compromised.
It's a critical single point of failure, yes. Best practice is to use multi-signature wallets or more decentralized governance mechanisms for controlling contracts that manage potentially billions in collateral value. It's something the team really needs to address for long-term trust and security.
Definitely sounds like it. Single key control is a bit scary for infrastructure.
It is. And finally, just to add, they also have this ambitious plan mentioned for late 2025, launching their own dedicated Layer 1 blockchain, the ARPA chain. That carries significant execution risk, too. Building a whole new L1 is a massive undertaking.
Okay, got it. Competition, vesting cliff, centralization points, and future execution risk. Quite a few things to watch.
So, just to quickly summarize everything, ARPA Network is using some advanced tech, TSS-BLS, and cleverly borrowing security via EigenLayer. Their main product, Rancast, provides provably fair random numbers targeting that booming Web3 gaming market. And they've got serious institutional backing confirming this strategy.
Right. And for me, the big takeaway is how they pivoted. They showed real strategic maturity, moving away from the really hard, maybe too early MPC tech towards something the market clearly needs now, randomness, and using cutting-edge tools like EigenLayer to get a competitive edge.
That's a great summary of their journey, which leaves us, and you listening, with a final thought to chew on. ARPA has this unique security angle, borrowing Ethereum's might via EigenLayer. Can they actually leverage that technical and security edge to steal real market share from a giant like Chainlink?
Or will that looming risk of the big token unlock in early 2025 create too much economic gravity, potentially overshadowing their progress, no matter how innovative they are?
Exactly. It's that classic tension, innovation versus market inertia and economic pressures. Something to definitely keep an eye on.
Absolutely. Well, that wraps up this deep dive on the ARPA network. Thanks for joining us.
See you next time.